All right, here we are again. Pre-calc lesson 87, sum and difference identities and tangent identities. We have more trig identities we get to memorize. Yay! So the sum and difference identities. I hope you said yay to yourself just now at home. You do need to memorize these. They're also, I think, on that sheet I gave you. We have the sine of A plus B. This is the sine of A cosine of B plus cosine of A sine of B. A and B being two different radians that they give us, or two different angles they give us. Okay. If we have the sine of A minus B, this is the sine of A cosine of B minus the cosine of A sine of B, or the cosine of A plus B is the cosine of A cosine of B minus the sine of A sine of B, and the cosine of A minus B is the cosine of A cosine of B plus sine of A sine of B. Alright, now let's look at some ways to remember this. Let's look at cosine first. If there's a minus here, there's a plus here. Remember, cosine is x. X is always opposite and different, so that's you can remember it. Plus, minus. You could also think cosine likes to get cozy, so you have cosine and cosine. Okay. Sine always has sine first, then cosine. I have no good ways to memorize that one. Okay. So, let's do a couple examples. With this, we want to simplify the sine of theta plus pi over 4. Okay, so we simply plug it into our formula, sine of A plus B. This gives me the sine of A cosine of B plus the cosine of A sine of B. My A is theta, my B is pi over 4. Now we know the cosine and sine of pi over 4. They're both root 2 over 2. So this gives me root 2 over 2 sine of theta plus root 2 over 2 cosine of theta. And these both have a root 2 over 2, so I can factor it out. So I have root 2 over 2 times sine of theta plus cosine of theta. La 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 la. That's my answer. Let's do another example. Okay, simplify the cosine of theta plus pi over 2. So, again, we plug it into our formula. This is the cosine of A cosine of B minus the sine of A sine of B. Now, pi over 2, we should know what that is, right? In your unit circle, it's this value here, which is 0, 1. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1, so this is just minus 1 times the sine of theta. So, minus sine of theta. Woohoo! Okay. All right, let's do a couple other examples. We want to find the sine of 75. Well, okay. Well, what we're going to do is we're going to break it up into different angles that we know. So the sine of 75 I can write as the sine of 45 plus 30, which I should know what both of those are. Okay, and I'm going to plug it into my formula. So this gives me the sine of 45 cosine of 30 plus the cosine of 45 sine of 30. Okay, now let's draw a reference triangle. Sine of 45 and cosine of 45 we know are both root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2, and sine of 30 is 1/2. So this gives me root 6 over 4 plus root 2 over 4, which I'm going to write as one fraction, root 2 plus root 6 over 4. It doesn't matter if you write root 6 first or root 2 first. Doesn't matter. Let's do another example. The cosine of 15 we want to find. This one's a little different. I'm going to write it as the cosine of 60 minus 45. Ooh. Okay, so if I do this, then in my formula, I get the cosine of 60 cosine of 45 plus sine of 60 sine of 45. Now we know from our triangle up here, cosine of 60 we have 1/2, cosine of 45 is root 2 over 2, sine of 60 we have root 3 over 2, sine of 45 is root 2 over 2. So this gives me root 2 over 4 plus root 6 over 4, which again gives me root 2 plus root 6 over 4. Woohoo! Okay, now let's talk about tangent identities. Okay, I'll do a new page. Okay, now tangent identities, they all start at remembering that the tangent of theta is the sine of theta over the cosine of theta. Okay? Now, we know, right, that if I was to look at this, right, I have all of my different identities for sine and cosine. We're going to develop our identities for tangent plus and minus. So let's look at the tangent of a plus b, which is the sine of a plus b over the cosine of a plus b. Now, I have a formula, identities for sine and cosine. So this becomes the sine of a cosine of b plus cosine of b sine of a, all over the cosine of a cosine of b minus, sorry, that shouldn't be plus minus, sine of a sine of b. Okay. Now, what I want to do, okay, is I want to change this all into a couple different fractions. Okay, I want to focus on everything that's going to make this 1. So I'm going to divide every term by cosine of a over cosine of b. So I get sine a cosine b over the cosine a cosine b plus the cosine of b sine of a over the cosine of a cosine of b, right? I'm just doing the same thing to all of my terms. Cosine of a cosine of b over cosine of a cosine of b minus the sine of a sine of b over the cosine of a cosine of b. Now I'm going to cancel things. I'm going to cancel my cosine of b here, my cosine of b here, my cosine of a and my cosine of b here. Okay. Now what I'm left with, I have sine of a over cosine of a. That's the tangent of a. Then I also have, this should be cosine of a. Sorry, wrote that backwards. That should be cosine a sine b. So then my cosine a's cancel, leaving me with sine b over cosine b, which is tangent b. On the bottom, I have 1 minus. Now this, I have sine of a over cosine of a, sine of b over cosine of b, which I can write as tangent of a, tangent of b. And there you have it. This is the tangent of a plus b. This is the formula you have to memorize. This is another identity. Okay? Now let's look and do the same thing for tangent of a minus b. Is the sine of a minus b over the cosine of a minus b. So on bottom, I will have the cosine of a sine of a plus the cosine of, I was writing sine. La la la. Cosine of a cosine of b plus sine of A sine of B. On top, I will have the sine of A cosine of B minus the cosine of A sine of B. I'm going to do the same thing. I'm going to divide everything by cosine of A cosine of B. So I'll have the sine A cosine of B divided by the cosine of A cosine of B minus the cosine of A sine of B over the cosine of A cosine of B, all over the cosine of A cosine of B over the cosine of A cosine of B, plus the sine of A sine of B over the cosine of A cosine of B. Now here, my cosine B's cancel, my cosine A's cancel, everything cancels, leaving me with the tangent of A minus the tangent of B all over 1 plus tangent of A tangent of B. This is the tangent of A minus B. Okay, those are the two formulas. Here, we're going to add to our list. So let's use them in some examples. Example 5, we're going to do the tangent of theta plus 45. So, okay, this is just like the tangent of A plus the tangent of B. So this gives me the tangent of theta plus the tangent of 45 over 1 minus the tangent of theta tangent of 45. And we know that the tangent of 45 is 1, so this gives me the tangent of theta plus 1 over 1 minus the tangent of theta. Let's do another one. Tangent of theta minus 30. This gives me the tangent of theta minus the tangent of 30 over 1 plus the tangent of theta tangent of 30. Now 30, 60, 90. Tangent of 30. So tangent of theta. We know that the tangent of 30 is opposite over adjacent 1 over root 3, which we rationalize as root 3 over 3. And the bottom becomes 1 plus root 3 over 3 tangent of theta. Woo! Okay. Let's do an example with numbers. Tangent of 75, which we can write, again as we did before, as the tangent of 45 plus 30. So we get the tangent of 45 plus the tangent of 30 over 1 minus the tangent of 45 tangent of 30. Tangent of 45 is 1. This becomes 1 on top plus the tangent of 30 we already did was root 3 over 3. And it'll be the same thing here. We'll have root 3 over 3. Remember, you have to rationalize denominators and simplify. So I'm going to make the top into one fraction, which is 3 plus root 3 over 3. In the bottom, I have 3 minus root 3 over 3. And I multiply by the reciprocal of my bottom. Distribute everything, so I get 9 plus 3 root 3 over 9 minus 3 root 3. And again, you have to rationalize the denominator. Multiply by your conjugate. I have 9 plus 3 root 3, 9 plus 3 root 3. We multiply all the things. We know that our denominator, we have 9 squared minus 3 root 3 squared, which is 9 times 3, which is 27. On top, we get 81 plus, we'll have 9 times root 3 and 9 times root 3. So that would be 27 root 3 plus 27 root 3, which is 54 root 3, plus 9 times 3, which is 27, root 3 times root 3. So we do 81 plus 27 on top. This gives me 108 plus 54 root 3, all over 81 minus 27, which is 54. We can definitely simplify that because 108 divided by 54 is 2. So this gives me 2 plus root 3. Whew. Now you could have done the same thing here. You could have left it as 1 over root 3 and not had to rationalize the denominator here. Doesn't matter. Okay? As always, if you have any questions, bring them to class tomorrow. That is all for